Tonight, we examine the mystery of why your mother never comes to visit anymore. And finally, we look at the common conundrum of the universe. Where do all the socks go every time you do the laundry? Join me. Maybe you can help solve a mystery. Greetings, the Astro 30 here yet again with another fun-filled episode. Sitting up on the desk there is a bag of goodies. That must mean only one thing. It's project time. Yes, I know, I've got several projects already on the go that I haven't completed yet, but this one's only a one-day project, so let's have a look at what we've got. Absolutely nothing. Oh no! Oh no! No, seriously. I have, making a bunch of noise, a little project case. It's HB5970. It's 140 by 110 by 35 millimeters high. And a kit. This is a chemo electronic or chemo, whatever. And it's a 1 watt amplifier. There's the components section and PCB in there, and it's using an IC I've never seen before. So this is roughly $10 from JCar, and it's catalogue number KG9032, and you should be able to assemble this in about 15 minutes. I've also got an AS3006 76mm 8 ohm 1 watt speaker. They're about $5.50, and I've used these before. They're a nice little speaker. There we go, that's the speaker there. That's going to be inside the case. For about $15 I also bought another glue gun, because, well, they're handy to have. My old one's in storage. I don't have access to storage at the moment, so I just bought another one. It's got some self-adhesive rubber feet, catalogue number HP0815. And finally, a 2.1 inner diameter chassis mount or panel mount, DC adapter socket, and a BNC socket. So, what am I doing? Well, there's been many a time when I've been testing amplifiers and the such that I need a simple signal tracer, because it's easier probing around the circuit listening for a sound than it is to keep constantly turning your head to look at the scope to see if you've got a signal there. So that's what I'm going to do. For about $50 I can build a simple signal tracer. So first and foremost, I'm going to make sure that my adapter actually fits into here. Yes, it does. I believe it's making good enough contact, so that is a 2.1mm 5mm jack. So that fits just perfectly. That's fine. This is also switched, by the way. Okay, so I think I'm going to open the kit now. There we go. That's a useless bit of paper. That, I'm hoping, is the assembly instructions, which it looks like it is. Oh, that's very well laid out. Yeah, we'll have a good look at those in a second. And this is just part identification information for, you know, pinouts of transistors and LEDs and stuff. It's not really relevant to me, but it may be relevant to one of you. So keep that because it's handy. As for the parts, throw that away. So that's the bag of parts, very neatly packaged. So let me just open the bag here and pull out just the PCB. very well made. Like, yeah, it's pretty nicely laid out too. It's mostly all the coppers on the front and the back, which is interesting. It's the same. And that's the IC. It looks like it's a TAA611. Never heard of it. Alright, well there's the data sheet for it. It's a 1.8 watt at 9 volt into 4 ohm output power, low distortion, low quiescent current, high input impedance. The absolute maximum voltage you can put on this is 12 volts. The input voltage is between 50 millivolts and 12 volts. I'm assuming that's the audio input voltage. Output peak current is 1.35 watts. It's just a basic looking IC. It comes in 2 types of packages. And there is their schematic. Now, looking at this, they've got a diode here which I believe is only purpose is to discharge this capacitor C3 here. I might include a diode from my DC socket, so as a wrong way protection diode, so it's not going to destroy the circuit if the supply happens to be backwards. There's not much to talk about. However, well, this is kind of nasty. They've got the output from the positive rail through the speaker, and this is what the hot signal will be coming off, which is pin 1, which is the bootstrap pin. And it comes through this capacitor, which comes off pin 12, which I believe is the output. I'll just verify that on the data sheet. Yes, indeed, it's either pin 2 or pin 12 is the output. In this case, they've got pin 2 going through a capacitor to part of the bootstrap circuit. All this is bootstrapping by the looks of things. So it's not that terribly complex. And down here they've got information for how to connect an external volume potentiometer, which is not included. And they say a maximum supply of 6 to 9 volt DC at 360 milliamps minimum. My plug pack is 500 mAh, I can't talk. So that should be fine. So what I'm going to do is for the external connections in and out of the board here, I'm going to use PCB pins, which are not included, but I have some. It just makes the connections a lot easier, I guess. But first, before I do that, I'm going to take my case, open the packaging, because what I want to do is, I don't need that anymore. There's the screws, keep it to the side. There's the 2 panels, don't need them. Right, so this is the top, this is the bottom. What I want to know is where I'm going to place the said PCB so it's not going to interfere with my speaker driver. So if I just mock this up, I'm pretty sure that I can put the speaker towards the back in the center and the PCB towards the front. Well, at least that's the theory. However, I might turn it backwards so the connections are at the front here. I want to leave room for my potentiometer, which I do actually have one sitting here in the background, because it'll be here somewhere. Righto. Yeah, no, that should be fine. Should be fine if I put it there roughly, because it's easier when it's not populated to actually draw around my holes. I mean, I could measure it. In fact, I might actually measure it. Alright, according to this, we are looking at 39mm between holes. Okay, so it might be in my best interest to actually drill 2 holes in the case first. Looks like it wants to piss down with rain too outside. Okay. Masking tape is your friend. It just makes it easier marking stuff that's all like holes for drilling. Sorry, I was having a little bit of a focus issue there. Okay, so that's going to be to the front edge, 13mm. Pardon. 13mm. I'll just use this as a straight edge, I guess. It's the handiest thing I had. Like so. Alright, so I need to find the center. So that's 140 thereabouts, which is 70. So 70 is the center. And it's 39mm. So if it was 40mm, that would make it 20. So it's actually 19.5. So we have a hole there and a hole there. And that's roughly in the center of the case. And the PCB almost. It's this one of them's off slightly. So I might take him back a bit. Yes, this is guesswork, but that looks more central. Okay, I'll drill these holes and then we'll come back. Here we go. Now let's see how well I did. That is almost perfect. Take the tape off. Oh, that's perfect. I'm quite happy with that. So what I might do is deburr this side. Don't know if it's exactly straight. It doesn't look that straight, but whatever. Right, I just spent 20 minutes looking for these sodding screws. They weren't in the place where I left them. Well, they were in the place where I left them, just weren't in the right place. Okay, so that should be perfect. I'm going to use some standoffs. And I'm going to see if this board will fit on it, which it should. So I need to find a screwdriver because I don't have one to hand. I hope no one's bored yet. I haven't really even done much except screw around with the case. Do that one up and this one up. Go, and I will use another 2 of these screws just to make sure the board will screw to the case without too much interference, if you know what I mean. Yeah. Bloody gravity. Well, that screw's gone. Straight onto the floor. Seriously, come on. Yes, that'll do up nicely. Not a problem. Perfect. And the height of the case should be high enough. Like so. Yeah, to accommodate the tallest component, which is the large electric capacitor, which is, I have no idea what it is right now. 470 microfarads, 16 volt. So yeah, there's plenty of clearance there. That's good. And the speaker will live in here somewhere. This is awkward, but somewhere there like that, you know. You can probably even go right in the center of the case without interfering with the circuit board in any way. I'll look at that last, but now that we've got part of the mechanical out of the way, I might as well put these rubber feet on, because I don't need to drill any more into the bottom of the case. You know, this is like unwrapping Christmas presents. Anyway, this is going to be fun to edit later. So I'll stick one there. A little bit crooked, but doesn't really matter. One there. Gravity is really starting to annoy me today. One there, and one there. I wonder if that will come back off. Yes, it will. Straighten it up. Perfect. Well, sort of. And that'll stop it sliding around. So that's all that purpose is. Now, let me clear some stuff, make a coffee, and then I'll go and start assembling this PCB. Alright, so I'm about ready to assemble the kit. It only has two resistors, and that's what I'm going to start with. One's a 47 kilo ohm and one's 160 ohm, and they're using really microscopic resistors that you often find in those like Sony amplifiers, Pioneers, Technics and stuff. These are real old school by the looks of things. Now that looks like my 47K, because I can just barely read the bands. It goes yellow, purple, orange, which is 47K. So the other one must be 160 ohm. It looks like it starts with a brown, it's the wrong way around, brown, blue, black. So yeah, 160. So you will need this little pamphlet that came with the kit, because it gives you all the part numbers and what the values are, because it's not printed on the PCB, it's just printed R1, R2, C1, C2, etc. So to make sure you get the right part in the correct place, you're going to need the component listing. And Danish Dart, if you're watching, I'm still using that roll of solder you sent me 2 years ago, which was about a third of a roll, and it's nearly run out. Anyway, I'm not going to take too much footage of assembling this PCB because I don't really see the point. It's reasonably easy to solder to. Before I get too carried away, I'm going to solder in some PCB pins, which are probably going to be all crooked, but every tool has its use. I'm using this jig to just gently heat what I've soldered in for the PCB pins, and this extra arm here, just to help pull them straight, which is nice. And there we go, the PCB pins are installed and they're reasonably straight. Now I can move on to the rest of the components. Okay, and I have now encountered my first stumbling block here. This capacitor has no printing on it, so there is no idea what value that's supposed to be. However, all the other capacitors are marked as to what their value are, so all that's left is 270 picofarad. I don't know if this is 270 picofarad because it's not printed. Correction. I don't know if the camera can see that, but there is print on it, and it's dull red or brown colour, and it's very faint, but it does say 271 on it. Okay, well that's good. Nothing worse than not being able to identify what the bloody hell a component is. So I'm going to pop this in where it goes, which is C7 I believe. Yes. If I can get the stupid band tape off. And This board smells kind of funny when you solder to it. Smells like wet cardboard. It's probably a cheap Bakelite PCB. Because it doesn't look like FR4. Yeah, it's hard to tell whether that's fiberglass or something else like Bakelite. Anyway, that's irrelevant. So the assembly's coming on. As I said, I'm not going to take much footage of this because there's nothing really to talk about with it. I just have to put the rest of the components in, which is 3 electrolytic capacitors. I can pick the blaster thing up. And the IC. Right, so we're up to this really dodgy looking IC, which should be relatively painless to install. So that capacitor is way in the way. And I've just got to get the oh, there we go. That was relatively easy. And then it's just a matter of soldering the pads on the other side. Make sure you've got the IC the correct way around. The notch should point to the 470 microfarad capacitor. So if this doesn't work, then we've most likely got a dodgy IC. So I'm going to put this into my handy little jig here so I can rotate this around at 90 degrees so I can at least solder one of the pins in. That one's good enough. No, I'll try another one because I can't quite get the soldering iron in where I want it. Okay, that's one soldered in. And then one up top here. Make sure it's still straight, which it is. And then I can solder the rest of the pins on the underside here. Because I'm soldering directly to the IC, keep the dwell time minimal. Like it shouldn't take any more than 3 seconds per pin to solder. Or else you'll overheat the IC and damage it. At least this is a single circuit board design, so if the IC ever had to be replaced, you bitch. You bitch. It'll be relatively easy to replace. That's a no connection pin anyway. I'll just desolder that one. I'll solder him back up in a minute. There goes gravity again. My bulb fell on the floor. Alright, resolder the pin I just buggered up. And there we go, that's the IC now installed. And that's pretty much the assembly of the kit done. Just pick my bulb up off the floor. Gravity. Alright, it wouldn't be an Astro Electronics Lab video without me swearing at something. Alright, now we need to test it. So, excuse me, what I need to do is hook up a power supply. And I'm going to use my bench power supply for that, and I'm going to set the supply to around about 8.5 volt, which is roughly what the voltage will be going into the circuit after the adapter is plugged into the socket and it goes through a protection diode. As this will run between 6 and 9, maximum of 12, we should be pretty well right. So, assuming everything is soldered correctly, all I need to do is hook up a positive and a negative, an input signal and scope on the output, and we'll see what this actually does. Okay, as messy as that is, I have got everything set up. I've got some fly wire leads wrapped around the posts so I can connect the power supply off elsewhere so it's not shorting. I've mounted the board into the bottom of the case so it stops it from moving around on me. Got the oscillator hooked up through a potentiometer to limit the incoming volume so it's not distorting the hell out of the IC. Got a basic dummy load there that I built a few weeks ago. It's two 4 ohm loads and I've just put them in series with each other to make 8. Oscilloscope 1x probe across the output, or across the resistor bank I should say. My oscilloscope sitting there off to the left, and the power supply is preset to around about 8.4 volt. So if I turn the supply on, we do have an output straight away, and it's clean. Look at that. Let me just take that out of times 10 mode so we can actually see the correct voltage. Alright, we're around about 500 hertz going in, but that's alright. That is a spec on the screen. And currently we're pushing out 0.39 volt. So let me drop the sensitivity off on the scope. Wind my potentiometer up. We're getting 1.3. Interesting, it's still not even clipping yet. Okay. We're at 3.35 volt roughly, peak to peak. There we are, it's clipping there at around, see if I can fine tune that. I want to say we're outputting 5.6 volt peak to peak into an 8 ohm load. Quite good for a little IC like that. It is getting warm, but I'll back my potentiometer off to almost nothing so it's not heating the IC up unnecessarily. So let's find out what that power output relates to. Alright, so we got 5.7 volt roughly peak to peak coming out. By that by 2 will give us a figure of that. Multiply it by itself. There is an easier way of doing this. Divided by the load, which is 8, is going to equal 1.1 watts. Or actually less than that. 1 watt. So it is actually producing 1 watt clean sound before clipping, which is good. So let's try it into 4 ohms. So I'm going to turn the supply off and I'm going to reconfigure the test equipment here. Remove that one, put that one there. Now it's a 4 ohm load. Turn the power back on. We do still have a signal. And yeah, we're getting slightly less voltage. We're getting about 4.48 volt peak to peak. So 4.48 divided by 2 is 2.24. Multiplied by itself, it's 5 divided by 4. Yeah, you're only getting an extra 200 milliwatts out of it. Now that's peak, mind you. So, what did I say, 4.48 divided by 2, multiplied that by 0.07, gives us that, multiply that by itself, 8368, was that divided by the load, is only 627 milliwatts RMS into 4 ohms. I had 5.7 volts into 8 divided by 2 multiplied by 0.707 equals that, multiply that by itself, yes it's boring maths guys, divided by the load, 500 milliwatts roughly into 8 ohms RMS. Okay, so we know what the power output figures are, so all I've got to do now is finish off the hardware side of it, which is drilling the front panel, the rear panel for the socket, and doing the internal wiring and glue the speaker in. And then we'll hear what this sounds like going into a speaker. Yay. And there it is there, all completed. I'm the Astro 30. If you enjoyed this video, please remember to rate. No, I'm not serious. I'm nowhere near finished. I just put the case together just to see what it would look like. Looks fine. Just make sure all the panels fitted properly and the lid sits on there nice. I've also marked on the inside of the top lid here which way faces forward, so it can't be messed up because there's a recess on one side and a lip on the other, and the same is also inverse on the other corner. There's a lip and a recess on the top part, so the lid will only fit on one way. So if I start drilling into the case with it backwards, then my speaker is going to interfere with the PCB. and that's basically the end of that case. So that's what I've just done that for. So now I'm ready to do the first thing, which I'm going to mark out the holes for the speaker grill on top here, drill them, and then glue the speaker in with some contact adhesive, not hot glue, because I want to make sure that it has a good adhesive bond. And I'm going to put a power switch, which I've got here somewhere. Yep, got a switch. I'm going to use a blue LED, my potentiometer obviously, and I've got to cut the shaft on that down. I'm going to use the knob that's on it too, why not? And the BNC socket on the front, and drill a hole at the rear, probably on that side, to accept the DC socket. And yeah, about another hour and a bit, this will be completed. But right now I'm going to take a break, have a smoke, finish my coffee, turn the IA function on my camera off because it's on for some reason, and yeah, we'll get back to doing this project, huh? Oh, the power of the case. Ooh, it's a big ass knob. And as I've said multiple times on this channel, masking tape is your friend. Yes, I've got a little bit of grubbiness all over the case lid now because the pen isn't quite permanent, or fast drying anyway. So I've marked out a grid of 10mm squares within the confines of the speaker driver, and there's like 3 holes here, 5 there, 7 this way, 7 that way, 7 that way, 5 and 3. So it forms like a sort of a diamond. It's not going to look perfect. There are ones you can get on the internet that actually look like a proper circle, but actually drawing that out by hand is super annoying. So alright, I'm going to drill out all these holes. Drill on, you crazy diamond. Alright, there it is there. All the holes are drilled out to 4mm, and I've cleaned all the excess marker off the top of the case, so it's nice and clean. Being ABS plastic, it's very easy to work with, so it doesn't take too long to drill. It's not exactly neat. Some of the holes are slightly off, but that's what you get. The sun's out now, which is strange. Now, I just sat on something. My drawers. Alright, so the next thing to do would be, well, I need to clean all this crap off the desk first. Alright, with the desk clean, I'm now going to apply some contact adhesive to the inside of the case, roughly where the speaker's going to live. So, into the driver. Okay, I'm just going to press it and release, and I'll let that set up for about 5 minutes, and then I'll stick it down and put it to the side and do something else. Alright, it's been a few minutes, it should be good enough. So I'll put this, that's the front, yeah, no, that should be fine. I'll put him roughly there. I'll just line up the center part of the thing, which it doesn't want to do now, but it is lined up, so that's in the center. I'll put that to the side to dry and move on to doing some other stuff. And that other stuff is drilling the hole for the DC socket on the back. So I've measured in 15 by 15. Start off with a 3mm drill bit. Like so. Drill bit wasn't really tight. Doesn't matter. Now I need to size out the hole for this, which I have no idea what size that actually is. Perfect. Alright. I'll see how well I can do this with pliers. Probably should use a socket actually. Like a nut driver. That should be tight enough. Cool. So that's going to live there. Perfect. Right, now I believe this pin is the center pin, and this is a switch socket, so one of these other two pins is the continuous connection to the socket. So I need a multimeter. Right, so that should be the center. Indeed. That must be the switch. Alright, maybe the plug needs to be plugged in for this to work. Let's see, I'll plug this in. Now, it's the top one. Okay, cool, I know how that works now. So I've got a 1N 4007 diode, 4004 rather. I'm going to put that into our DC socket. I'm going to remove that. And I'm going to solder him in once I can get it wrapped, or at least wrapped enough. Probably be easy to do this out of the case, but I love living dangerously. That's hot. Alright, so that's the diode installed with the anode facing the socket. So now I'm going to do my front panel. Might as well, it's nice and handy. So something like that. Input socket goes here, that's 15mm in from the edge, which should have enough clearance. Pot goes next to it. Then we have the LED and the power switch. I could move the LED probably closer to the power switch, but input socket to center of pot is 25mm, so the center of the switch to the center of the LED is also 25mm, just to make it look even. Okay, let me get to drilling that. Alright, I've encountered another problem. My pot is coming into contact with that board. Now, to save moving the board, I can just lower the board, I guess, but then I'm going to run the risk of coming into contact with that outer pin there. So I might use a double nut method instead of the standoffs and some screws to pass through and see if that alleviates the issue. I don't really know. I don't want to have to move the board over and leave holes in the bottom of the case if I can avoid it. Well, if I can get this in here. Single nut, and the nut on top just clears this leg of the variable resistor. So yeah, I should have really thought about that before drilling the front, but it doesn't really matter. So now what I have to do is cut the shaft off of this down to about 10mm, should be long enough, I think. Yeah, about 10mm, and bolt everything in. Perfect. Oh, and I've also bent up the leads on the potentiometer to clear the bottom of the case, and also cut off one of the little pillars that was standing up, which was going to interfere with a pair of side cutters. Alright, that's awfully awkward looking, but I don't know if I'm going to be able to cut it like that. I may need to be where you are, so I might try cutting upwards, I suppose. Yeah, it's at a funny angle. Well, it was all the way through anyway. Sweet. Lost a bunch of shit behind my cabinet. I'm going to have to pull the cabinet out later after I've finished and retrieve them. Got the hot glue gun heating up, and I'm going to hot glue my LED in. Yeah. And I'll do it so that the anode is facing upwards. That's the cathode, isn't it? Yes. Cathode facing down. So I've just got to wait for the gun to heat up, and I might put some hot glue around these other components to stop them twisting around. Don't know if it's going to do anything, but it'll make me happy. I think it's ready. Yep. And they're nice and deep, boy. Nice and deep. I hate hot snot sometimes. Big blob of it there. Alright, might as well give the DC socket a bit of some hot snot as well. So I don't think it's going to do anything, but it'll make me feel better. Right, that's that done. Alright, I've got it mounted in my jig to help me. So I'm going to wire up the LED first. I'm using a 33K dropper resistor because this is a fairly bright LED. So I'll just trim off my anode lead, like so. So what I want to do is I want to pass the resistor, something like that, and my pre-cut cable through the eyelet of the switch. So this goes up to the rest of the circuit. Solder that in. Right. Trim that bit off. And refashion this resistor to go towards the LED. So I'll just trim off about that much to do. Bend that around. Contact the LED. It's a bit haphazard, but whatever works, huh? Nice liberal amount of solder on that. That's the anode wide. Bend it up a bit. Okay. And then the negative lead I'll put into the anode and then off to the circuit, so I can trim that. Did I say anode or cathode? I meant cathode. Trim that end off. Alright, I'll get back to that. What I'm going to do now is I want to put a capacitor between the input and the control. So I'm going to use a 1 microfarad non-polarized, one of these, and it doesn't really matter which way around it goes. Put it into the socket and then bend it to fashion to fit over here. I might leave the legs the length they are and just put some heat shrink on the end of the legs. This is an unintentionally long video. Okay, that's that done. As I say, it doesn't really matter which way around it goes, it's non-polarized. So I put one end in there. Solder him in. It's got to go to the clockwise position of the potentiometer, which is here. So I want to tin the end of that. Okay. Got this awful sinking feeling. Alright. That's fine, it's just sitting up in mid-air. Now I need to get the ground connection over to here plus the audio out connections I don't know if I'm going to use shielded cable for that or not. Actually, I don't think it's really relevant if I do. It's only going a short distance. Alright, about half an hour later, as tedious as that was, it's internally wired now. The only thing I've got to wire up now is the speaker driver, which may prove a bit challenging because the wires are in the wrong place, so I'll just move that to the side like that. And do it this way. Whatever works. Now, I'll pass the wire. Yeah, that's awfully awkward now. Yay, cool. Right. I'll just do it like that then. Seems to be the easiest way to do it. As long as it's soldered and functional. No, the soldering tip did not touch my finger. It just barely brushed it. Alright, you're going to prove to be a pain in my ass, aren't you? That's what I think of you. Okay, the speaker is soldered. Now, I hope all that work was worth it. It should be. Put that to the side. Now I'll plug in my DC adapter. And nothing is on yet, so I'll turn it on. Oh, lights up at least. I can hear something coming through the speaker. So that 33k resistor is fine. So I'll hook up my probe. Beautiful. Alright. I'm happy about that. Gonna have a nice wank about that later. Alright, so now I can put the screws in. Now that I know that it works. I'll hook it up to an oscillator in just a moment. Pretty. There we go. How awesome looking for a homemade project is that? I think it looks reasonably nice, to be honest. I mean, you could put labelling on there with a dyno labeler or something, but I know what it does and what each thing does, so there's no real need to do that. Alright, let me clean up a bit and I'll hook up an oscillator and see how clean the sounds coming out of it. Alright, oscillator's hooked up to the probe. Plenty of gain there. And good thing about an oscilloscope probe, I can put it into times 10 to reduce it. And it barely comes out. Sounds like I'm swearing. That's serving its purpose. Okay, it's a couple of hours later and I'm ending the video now. I was talking to my flatmate about an amplifier. That's the Signal Tracer project complete, and I'm quite happy with how that turned out. And I hope you enjoyed this video. If you did, please show your support by going down below and rating the video, commenting and subscribing if you haven't done so already. There's also links in the description to my PayPal and my Patreon and my Facebook page if you wish to partake in that as well. Anyway, this is Yastro3 saying see ya. Have a great day.
90% of the time I have no idea what the f I'm talking about.